Okay, so we should be live now. Let's see how this works. And so chat goes here. Yeah, okay, so it looks like you can see the chat stream. Sorry, the stream on YouTube. So I'm gonna wait a few minutes till people join. Okay, so let's increase the font size so everyone can see. Yeah, 14. Is that better now? Okay, so I think we can start now. So what I want to start with is just talk about what are we going to do today. Okay, so here's a question. Does Deno still use C++? Yes, it does, because V8, the JavaScript engine that Deno uses, is written in C++, so we need to spin up the V8 isolate, and then we use something called libdeno to bind to this isolate in C++, and then we can call the APIs in Rust. Okay, so let me start by talking about what we'll focus on today and explain a bit in depth how Deno uses V8 and how it passes messages between JS and Rust. So on the diagram, in the diagram, you can see a simple schematic how Deno works. And yeah, so V8 is the JavaScript engine that Deno is running, and this engine is, Well, basically, if you want to use V8, you need to spin up an isolate. It's V8 term. It describes a single process that is running and interprets your JavaScript code. So, since Deno is a Rust project, it's built using Cargo now, and everything that starts inside Deno process is called inside Rust. So we need to somehow call v8 isolate, which is written in C++ from Rust. And this is done by a binding called libdeno, which is a C++ code. And let me quickly show you what is libdeno. So we can see the API of libdeno both in Rust and in libdeno directory. So this is basically a wrapper on C++ isolate that allows us to call certain C++ functions from Rust. And basically there's a single way of calling Rust code from JS code, and this is done using something called Deno core, which is basically binding from JS up to Rust. And yeah, this is outdated. This is now called deno.core. And let me show you how it looks. So here are our TypeScript declaration file that shows you whole Deno core. And what Deno core exposes, the most important methods are send and receive. And send method basically allows you to call some Rust code from your runtime in JS. And everything that is called in Rust has to be an op, which is identified by op ID, which is just a number, and right now this is hard-coded, but we'll get to that later. Then you have control buffer, which is just a buffer. You can put actually anything inside it. And right now in Deno we use two types of serialization or dispatching, and one is just JSON. So we serialize everything into a JSON string and then we encode it into a buffer. Or the second part, the second dispatch is called minimal, and basically it's just custom binary format which exchanges three numbers, I believe. And yeah, there's the third parameter that's called data, and that's a zero copy buffer. So if you pass a buffer in JS as this third parameter, then when you read into something, when you write something to it from Rust, then this buffer is not copied from JS to Rust, it's shared between those two lands. And yeah, okay, so someone wants to have a bigger font, let me change that. Is that better now? Okay, so yeah, that's the send method. So this method allows to call some Rust code from JS code, and it's done using so-called ops. And then we have this receive method that takes a callback, message callback. And message callback is basically a function that takes an op ID and again raw buffer. And then in JS we need somehow to deserialize this buffer, and again it's either JSON or it's minimal serialization. So yeah, this custom format we use for read and write operations. So yeah, and let me now show you the Rust part of this mechanism. So the exact place that receives the messages and then handles them appropriately. So this is done in isolate.rs, and there we have set dispatch method. And this method takes a function, and the type of this function is crucial to this whole concept. So on JS side, we had an op ID, which was a number, then we had a control buffer, and then we had a third parameter, optional one, called data, which I told you is a zero copy buffer. And in here we can see the signature of the function is actually the same. So op ID is just a number underneath. Oh, sorry. Then we have some control buffer, which is just vector slice of bytes. And then we have this option pinned buffer. So this method takes the exact same parameters as the JS one. And what it returns, it's called core op. And core op is a type that, well, we have some logic hard-coded that can turn core op back into a JS response. And I'll tell you about it more, but later down the road when we get to the essentials. And then inside our implementation, when we create a new isolate, then we use this set dispatch method that will handle incoming ops from the JS side. And let me show you worker.rs. That is actually a file that is used in Deno CLI, which is separate crate that implements the whole Deno binary that you download. And in here we're creating a new isolate from the Deno core crate. And then we're using set dispatch method to add certain handler for our ops. In case of Deno CLI, this is done on the state. The state is, well, it's a Rust structure that is that lives inside CLI crate, and this is gonna be one of the points that we're gonna address when we're refactoring the dispatch. Unfortunately, my PyCharm is moody and doesn't want to add colors. Okay, so let's go to dispatch method on the state to see what's going on. Yeah, so in case of current master branch, dispatch just forwards everything to dispatch function inside ops crate, but mind that the first argument is actually the state, not the op ID, and let me show you why. So if we go to ops mod rs, and then we look for function dispatch, then we're coming to the central place that we're going to be refactoring today. And in here you can see there's actually hard-coded match statement that basically maps op IDs, which are numbers defined in the same file, to handlers, which are just functions inside other modules in this crate. And yeah, that's the problem, because everything's hard-coded now. So if we want to add next op, we need to update this file and add new op ID, and then write another closure and call the appropriate handler. So after we do that, we have to go to dispatch TS file where we have duplicated IDs, and then we can add a new op. So obviously this solution is not very great, because for one, it won't scale. Two, it's cumbersome. You need to remember to update it on Rust side. You need to remember to update on TS side. And there's no public API, so actually you cannot add an op from JS code, which, yeah, it will be desirable, I guess. It's actually the whole idea behind native modules. So once we expose the API for native modules, they will just expose certain ops, and ops are obviously something that has a signature code. Yeah, here it is, core dispatch function. So a function taking nobody, control buffer, and zero copy buffer. So yeah, actually we have a few PRs and issues talking about this whole concept of Deno dispatch, and yeah, there are some related issues, including one of the eldest ones in repo that are still open, so importing a native module. And there's another one that all of ops code should live together. So what we want to achieve is also having each op, maybe not each op, let's say we have some file system ops that are inside ops fs, and we'd like to move them to separate crate and then move all IO ops to a separate crate. And what we want to do along the way is take JS code, or sorry, TypeScript code for them and put them inside one directory. So you will have ops/fs crate, which will contain all of the ops you see here, and then there will be like main TS file that will contain all TS code for this op, and then we can test them in separate and actually ship them in separate as separate crates. So then you can just take a bunch of them, recompile Deno, and have your own custom runtime with your custom ops. So yeah, let me see what I wanted to talk about. Okay, so let's talk what were the ideas for new dispatch. And yeah, I started with this issue, but actually it's not the first issue. It's just like a synthesis I did on this topic, and we settled on a few things. Actually, we discussed this mostly on offline, so I'll just briefly tell you about it. So actually, Andy Finch did a few implementations of this already, and actually I think all of them work. But there were some problems, including that was a lot of code. That was like 4 or 5K lines changed. And yeah, since this is a critical change, we optimally like to do it in as small pieces as possible, I guess. Yeah, so how do we update this dispatch mechanism so we can, for one, register ops before we're building the binary, Deno binary, and then how can we expose the API to load new ops as native plugins from JS? So the first thing, let's go back to Deno core. So the first thing is that first thing is we need to get rid of hard-coded op IDs between Rust and JS, because this is like the fundamental thing that we need to start with, and then we can go outwards and outwards. So yeah, let's start with this PR that I did a few days ago. And I thought I figured out how to share these IDs between Rust and JS. And I did it with Deno core init ops function, which I'm going to show you now. So this will be feed yeah, so initOps is again a JS function that would go to Rust, get all the registered ops that were registered during build, and then we can match them in JS, map their name to their ID. And so this is HTTP bench example. This is like a small crate that is designed to showcase how you can use Deno with like the bare minimums. It's just isolate registration and this single file is run. So yeah, in the main function, I wanted to call initOps to synchronize the ops from JS side that I registered up here. So yeah, this is like a class that we instantiate with name. We want to collect and save all those names. And then upon, sorry, let me first show you the Rust side for it. So this will be http bench.rs. Yeah, and I registered, I refactored the initial implementation of this file because again there was this set dispatch function that was hard-coded match statement mapping op IDs in Rust and then again in TS, and I introduced this register op API, which is basically storing a function inside a vector that is then looked up when the op is called. And here's the name of the op that, again, we'll have to share between Rust and TS, but I guess we can somehow automate it or just fall back to some defaults. Let's see down the road. So yeah, let's see register op. Basically, it's just a simple method on op registry, which is a vector of core op handlers. So core op handler is the function with similar signature to dispatch function, but note that there's no op ID. So, well, this type is actual handler. We pass it the raw control buffer and optionally zero copy buffer. And then it returns the core op, so the type that we know how to serialize between Rust and JS. So we register an op, we're getting a new ID, which is, well, if we have 5 elements in a vector, then the next ID will be 5 because it will be appended to the registry vector. And then we have this helper structure called opmap, which is just a hash map that maps the names to the op IDs. And what we want to do is send this opmap to JS upon startup. So in HTTP bench.js, we have this main function that calls initOps. And please note that before this was Deno core receive. I changed it to initOps, but that's not the final API. And somehow we want to get all the op IDs from Rust, and that's done in shared queue.js. It's here. So this is a little hack. I'm basically sending an op with ID 0, no control buffer or empty control buffer, and no zero copy buffer. And since it's in this code, we have to use bare minimals. I mean, something that is provided inside V8. We can't even use text decoder here, and yeah, I use this just from char code method that translates each byte into a char. But of course, this won't work with chars that are not UTF-8, I believe. But yeah, let's leave it for now. So yeah, I send So I want to get op map from Rust, which is a map between strings and op IDs. I want to parse it, and then for each op that we registered in HTTP bench, so listen, accept, read, write, and close, we want to assign this ID to the op, because when we create it in Rust, we don't know, when we create it in JavaScript, we don't know what will be the ID because the ops are registered in Rust. And it's Rust that tells you the IDs. Because in JavaScript, you can like switch the imports, and then yeah, the IDs won't be aligned properly anymore. Okay, so yeah, this is all fine. In shared queue, we parse this op map, which is serialized JSON on Rust side. And then for each send name and ID. So this is how op map would look like. Oops. And there would be like more ops. So once we parse this op map from JSON, then I wanted to call this set op ID method on each op, which is, if you remember, is a class instance. And yeah, it's fine. It works with HTTP bench, and this proven to be actually pretty fast as well. But a problem appeared when I tried to then use it inside CLI. So remember, this HTTP bench.js is just an example of using Deno core crate. It's bare minimum. In Rust code, there's like main function which just creates new isolate in place and runs one file that is HTTP bench.js, so this file. And then we move to CLI, which is again crate that produces Deno binary in the end that you can download then. And in CLI we have way more JS code that we provide. You know, all this fancy Deno.write, Deno.read, etc. are all ops that we provide out of the box in the Deno binary. And they're written in the JS directory. So if we go to JS Deno TS, we can actually see what's exposed on the Deno object. And yeah, all of this stuff is mostly ops. So if we go to link sync, it's just an op like in HTTP bench.js. You know, send sync, send async, so synchronous and asynchronous version. Then we have this op link, which is again hard coded in JS. So yeah, we could just port this solution from HTTP bench to CLI. And actually I did, but the problem is, because we ship so much JS code, we don't want to interpret it and run it over and over again on each startup of new Deno process. So what we do is we provide so-called V8 snapshot, which is a binary file that just is the dump of V8 heap, and then you can load this heap again, which is way faster than parsing all of this code on startup. So as you can see in this JS directory, there is like 50 or 60 files. So running them over and over again when you start new Deno process is just a waste. So we provide this V8 snapshot, and it's done using one of the other crates. But the problem is, when you create a new isolate before you load your snapshot, this shared queue structure is, this shared queue file is run again over and over. So even though it is inside this snapshot, I believe that it's like every time you start new Deno process, it's starting afresh. It's okay because this is really short file. This is like bare minimum to send messages between JS and Rust. So it's not that bad, but what it prevents from doing is this. So I exposed op class on Deno core, and I wanted the API to be that you create your own class that extends Deno core op, providing serialization. In this example, it's again some custom simple binary serialization. Yeah, so that was my idea for this API, but the problem is we reference here Deno core op, which lives inside this shared queue, which when we create a snapshot, we spin up new Deno process, load off all of the TS files transpiled to JS you see here, and then we're taking a snapshot of the heap. And op is registered then. Because its constructor is run, it's set inside this JS ops map. But the problem is, since shared queue is loaded every time you spin the isolate, the the op class that your op class was referring to is no longer the same one as Deno core op. And I'm not entirely sure that I'm right here, but I couldn't make it work with CLI. So this is where we're coming to actually coding, I guess. Let me show you another branch. Oops. Yeah, so this is another branch and another PR. This is register ops in CLI. And what this PR does is trying to use the same register op API inside the CLI. And since this Deno core op is no longer working when building a snapshot and then loading it, I decided to alter the API a bit, and let me show you dispatch TS now. So what I want to achieve, it's os.ts. So instead of calling Deno core receive with a message callback and then Deno init ops, I think we could pull it off using a single function that would basically register two callbacks. One is the callback that should be called when the ops are synchronized, and the other when there's an async message from Rust. So basically, if you do some async op and you await it, then we'll pull the ops in Rust side, and when your operation is done, finished, and ready to be sent back to JS, then this handle async message from Rust is called. And since we have two different ways of serializing messages between Rust and JS in CLI, which is minimal and JSON, let me show you dispatch minimal. Yeah, so what does dispatch minimal do? It has this arc argument, which means that you can send only one number to Rust from this method, and zero copy buffer. And why is that? Because we have two very hot ops that we want to be as fast as possible, and that's read and write, and they use this dispatch minimal. And then all the other ops use dispatch JSON, which is a really cool way of doing that, much simpler than flat buffers we used before. So yeah, you have your op which you give one argument that is, well, something that can be JSON serialized, and then you encode your message, which is, yeah, so JSON stringification, and then you encode your string into bytes and send it to Rust. So this is all pretty good and works fine for now in CLI, but now we need to somehow be able to register the ops in the files that are defined. So let's go to link.ts now. And remember, this is a new branch, so I ported the core op you saw in HTTP band.js to CLI, and I added JSON op and then minimal op. Well, where is it? Yeah. So now we have ops in JS that we like the API more or less. I think it's pretty elegant. You just register a new instance of a class. Then we have this method in Rust that can give us mapping of op names to op IDs. And now we need to somehow connect them, but make it work so even though we have V8 snapshotting, it will still work after the Deno startup. So the main difference is that it's not core op anymore, but now, oh yeah, this is wrong, so we need to fix this. So to do change to dispatch op, and yeah, dispatch op is the same class as core op that we saw before in HTTP band.js, but it's not provided in Deno core, but it's just a class of our runtime. So yeah, the fix to this problem with snapshotting is just moving the whole op registration process out of it, which I must say I don't really like. I'd like to have it all inside Deno core, but for now we can do that. And yeah, let's look for a workaround. So the workaround is not using a class provided on Deno core op, because once the classes are created and we save which classes were created in an array, inside shared queue that is again reloaded on each isolate startup, we just move this to a module that is snapshotted but is not reloaded when we create a new isolate. So yeah, what I did in this branch is move all of the logic related to op registration out of Deno core and into a separate module. And then we're changing the API of Deno core from receive callback to, let's say, init dispatch that will take two callbacks. One that will receive map of ops, and the second one that will receive messages from Rust. So yeah, so what we'll ultimately like to achieve is get rid of all this nasty serialization and promise stuff in here and move this whole logic for sending sync and async messages into this dispatch op class. And then when we have a new serialization type, say minimal or JSON, we'd like to have a class like this that exposes two static methods, encode and decode. Yeah. So encode will take some arguments that this type will interpret and understand. So in case of JSON ops, it's an object, and in case of minimal op, it's this arg, which is a number. So yeah, the encode will turn sorry, it's any array, will turn this array of args into a buffer, which is uint8 array, and then decode will so this will be response, which will be buffer, and then turn it into something that your serialization understands. So in case of JSON, it will turn everything, the response, into an object, and in case of minimal dispatch, I think it would result, which is a number. So this is more or less the API we'd want to achieve, and the problem to achieve it currently is promise ID. So yeah, because we want to move all of this stuff that assigns promises to async actions up the chain into the dispatch op. So we'll provide just like one class that is a bare minimum that can send messages to Rust and then receive them from it. And then we'll provide two classes, minimal op and JSON op, that know how to serialize its call signature into a control buffer for Deno core send method. So the problem is promise ID because since we're doing this all creating resolvable and receiving new promise ID inside of minimal op and then again inside JSON op, and the funny thing is, we have next promise ID in dispatch JSON and we have next promise, next promise ID inside dispatch minimal. So these are two different methods, and actually they can produce the same promise IDs simultaneously. It wasn't a problem, I guess. For now, we haven't had any problem with that, but I believe keeping it all inside one place and not exposing it to implementers would be a good thing. So in minimal op, this promise ID is serialized inside. Oh, it's not. It's serialized in here. So we have a scratch buffer which turns arg into control buffer, and it consists of promise ID as the first argument. And then in dispatch JSON, we have exactly the same thing. So we're creating new promise, and then we're assigning this promise to our arguments object. So we have two different mechanisms, and the promise ID is assigned in two different places. I don't really see a point in that. So what we'd like to do is move this promise ID out of this serialization and possibly into dispatch method. Well, it's not this dispatch. So we have dispatch method, and I'd like to do this. So we move promise ID as argument to dispatch, and then we add it as an argument to message callback as well. So that way, the whole sending process between JS and Rust is completely unrelated to serialization scheme of the op. So we provide the most basic API to send something to Rust, but it's up to the implementer to wrap it in in some format that is easily understandable, like JSON we use in CLI. Okay, guys, so I'm gonna take like 2-minute break and be right back with you. Okay, I'm back. Let's get to work. So we want to move the promise ID as an argument to message callback and dispatch. That way we decouple the whole dispatching mechanisms from serialization. And then we should be able to refactor these dispatch classes into something more elegant like this. Yeah, so okay, this is gonna take probably traversing through 3 languages to achieve that, because bindings for this dispatch and set async handler are in C++, and then we need to adjust Rust code as well. And yeah, so we'll leave the promise IDs inside serialized data, so it works like it worked before, but we'll add additional arguments now, and then we can remove them from serialization. So let's get going. I believe this should be in binding CC. Yes, so receive is a callback, and it will be called somewhere here, I believe. Print evil context. Where is it? Deno buff. Yes, so binding, import buff, yeah. Oh yeah, sorry, it's Deno respond. Yeah, that's actually the method that calls the callback we provide via Deno core receive. Okay, so Deno respond takes the Deno type, which I believe is a wrapper around isolate, user data, okay, Deno op ID, and Deno buff. So Deno buff is this argument message, and we want to add promise ID, which would be a number. Yes, so current arc synchronous response. Yes, so in case of synchronous response and synchronous ops in general, we just use promise ID 0 to indicate that it's a sync op. Okay, so promise ID No, wait, let's start from dispatch, not callback. Callback is the last thing that's gonna get called. Let's start with dispatch. So dispatch is a public function that is exposed from Deno core, but yeah, I think it's just a wrapper around send. Let me check that. So dispatch, yeah, so dispatch is just a wrapper that makes sure that shared queue is initialized. Okay, so let's try to do that. Actually, guys, there's a problem. I'm on a wrong branch because we don't want to do that in CLI. We want to do that in Deno core HTTP bench first, and then I rebase this branch and implement it for CLI. So let me just quickly switch branches. Yeah, save it as temp. Yeah, okay. So yeah, so dispatch will take promise ID. I'm not using types here because this is a pure JS file. And yeah, this is promise ID. And dispatch takes promise ID as well. And now we have to update the send method, which again, it should be here. Yes. Okay, this should be pretty straightforward. I'm just gonna copy this. Promise ID, then this is args1, and everything shifts to args3. Yeah, I just realized that if we do that, we're gonna have to update a lot of crates later down the road, including compiler. But let's take care of that later. So yeah, args1, args2, args3, that's fine. Yeah, then I'll receive callback. It should be past promise ID as well. Then let's see. Then I'll receive callback. Okay, so this is a binding type. Yeah, so we'll have to update it in a few places as well. So promise ID, let it be U32. And now, yeah, promise ID in here as well. And by the way, what is the type of Deno op ID in here? Okay, so it's uint32. Yeah, that's fine. Well, Deno promise ID. Let's go with this for now. So that, and then we go to, yeah, that's fine. Yeah. Yeah. Okay, so let's look for this in Rust. So receive callback, Deno config, and it's pre-dispatch. Okay, promise ID U32 for now. And yeah. Oh, actually, this is one thing I did not talk about. So when implementing this new register op API, I still left the old API intact. So if you call isolate set dispatch, we'll use this dispatch callback that you provided, not the ops registered using register op API. So actually we can leave pretty much everything in CLI and compiler intact and just add it for our new API. Yeah, actually that's pretty good. So this would be promise ID, then in here promise ID as well. And then we'll have to change the op handler type. Or do we? Yes, so ops is core op handler. So we'd call it like, we'd change it to this. And actually the first argument can be used to decide if it's synchronous or asynchronous op. Yeah, and that won't be, then we won't need it to be inside JSON data, and then the op itself won't need to be aware of the whole concept of promises. It can just take the first parameter that is sync, and you just pass it a bool telling it if someone called it asynchronous or asynchronous version. Yeah, so let's see this core op handler. Where do we use it? And is it? Yeah, so basically it's just used for this new register op API, so we can safely let me think a bit more. So we have this call op, which should get promise ID, and in here respond op ID buff. Okay, so we don't even need to pass promise ID to op handler. We can just pass it a bool telling it if it's synchronous or asynchronous request, and the whole encapsulation of sync and async with promises can be kept just to this pre-dispatch method. Yeah, that's nice. So let me change it to let is sync equals promise ID equals 0. Then we pass it is sync, and then we can change respond. Yeah, let's do this. Okay, so promise ID would go here. Yeah. Okay, then we add U32 here, and then we'll change this to take promise ID as well. Yeah, then we'll respond, and then in C++, yeah, then we'll promise ID, and in synchronous response it's 0, so we can ignore this if, I guess. And then we need to update this bit to send promise ID as second argument and move buffer to third. And yeah, argc free, and in free okay, so that would lead us back to the async message handler. And I guess we can change signature of async message handler now. So let's go back to shared queue. Yes, set async handler callback. Async handler equals callback. Yeah. Yeah, okay, so we add promise ID to this function because it's the one that is assigned to Deno core receive. So basically it's the main callback that will receive all messages from Rust first, and only from within this one we call the actual handlers for ops, which is deserialized JSON or deserialized minimal. And in here you can see that this callback is actually conditional because, as I said before, we still can use set dispatch and or register op API, and this conditional basically ensures that. So if you set a handler using set async handler, then this is called. Otherwise, it just falls back to the handler of the op. Okay, so since we want this promise ID only in our new API, register API, we can, we need to change it. So if async handler, then we call async handler with op ID and buff, so the old API, and otherwise we call the handler with op ID, promise ID, and then buff. And the same, here. So if async handler, then okay, we need to parse it ourselves. Nothing, and then buff. So we can do this here, and then it's op ID. Oh, sorry, this is the structuring. So op ID buff. Actually, we're gonna use it. So yeah, okay, and you might think why there's this if buff statement inside as a handle async message from Rust. So Deno has two ways of responding to ops. One of them is shared queue, and the other one is just responding with a buffer. So the reason for this is because some messages are really small and responses for them are really small as well. And the others are actually big, like, I don't know, you try to read megabyte from a file, so you pass so we get a huge response, and this response does not fit into shared queue. So we're working on the shared queue right now, and this is basically big buffer that is divided into these sections. And if you have a small response, you can actually pass a few responses from Rust to JS at once. So if you do a lot of small ops, like small reads, let's say, I don't know, 10, 20 bytes, then you can push 10 results of these reads at once and return 10 results to JS instead of doing back and forth for each response. And this shared queue is working really well, so I don't want to change too much to it. And introducing promise ID is pretty disruptive already. Yeah, so basically if buff is the overflown response, huge response, and the other one is using shared queue, so we have this while statement that we just empty the shared queue, so we can call like 10 different async handlers in here. Okay, let's see if this compiles. I guess not, but fingers crossed. Yep. Okay, let's see. Cannot find promise ID in the scope. So isolate.rs 434. Yeah, so maybe buff should have, yeah, this should be different. Promise ID and promise ID here. And what is wrong in here? Yeah, user data, op ID, promise ID, buff. Oh, okay, it's fine now. Yeah, so expected free parameters. Isolate 263. Yeah, so we don't want to pass promise ID into the op. We want to pass isSync, which will be a boolean. So isSync, this is bool, and that would be the first argument. Yeah, op handler. Let's see the registry. So we want to change it to bool after all. Get op map. Yeah, we need isSync bool in here. This is just a hack. This has to be removed, by the way. This is a hack remove. Okay, register op. Yeah, that's fine. Okay. Promise ID, this is fine. This is not fine. Yeah, so we need promise ID here, which should be extracted from overflown response. Yeah, which is missing a type. So yeah, promise ID, promise ID. Oh, we're gonna change a lot of things. Set meta record. Okay, so I think that we're gonna have to change a lot of shared queue to get this to work. Shift. Yeah. Okay, so we basically need to synchronize both sides from Rust and from JS to work the same, and I'm afraid it might even mean changing some of these constants. Yeah, let's get to it then. So we want to push a third parameter, which is promise. Oh yeah, it's already here. Yeah, so then we have push promise ID u32 set meta, yeah, promise ID. Then we need to change set meta to get promise ID. Okay. Plus 2 promise ID. Promise ID. Okay, let's do the same in JS. Get meta. Yeah. Promise ID. Oh. And this is plus 2 promise ID. Set meta. Yeah. Promise ID. We need to set meta. It's already set meta. Promise ID. Now push promise ID and promise ID here as well. And now shift, yeah, here's promise ID. Path, promise. Yeah. Let's see where this takes us. Expected a tuple with 2 elements, found one with 3 elements. Okay. This is 672. Pending ops poll. Okay, we need to change the return type of pending op future to include promise ID. Okay. Pending ops push future 2. Yeah, we need promise ID in here as well. Yeah. Haha. So, compiling a snapshot did not work. Surprise, surprise. Okay, process didn't exit segfault. Yeah. Okay, that might be because no, we ignore promise ID before calling async handler. Okay, let's see if the example works. So Deno core HTTP bench. Okay, yeah. So Deno core compiles fine, Deno CLI compiles file, but we can produce a snapshot. That's fine for now. We're focusing on Deno core HTTP bench. So let's update HTTP bench RS code to use this new signature for ops. And this is 111. Yeah, so we take promise ID here. And yeah, here we can see that promise ID was taken from the record that, so basically the serialization mechanism in HTTP bench is the same as minimal dispatch inside CLI. So the promise ID is put inside the buffer with data. So yeah, we can now remove this and just use promise ID that is passed from the handler. Yeah, that's nice. Handler is sync. Okay, result. Yeah, that might work. Oh no. So what's the right, okay, so this serialized op, it's actually an op handler, core op handler, so it should have the same type as core op handler, and we added the first argument as bool. So this whole promise ID thing, yeah, so basically isSing is the first argument that is a bool, then we have control, then we remove the promise ID, then we can remove this isSync from here. Okay, main panicked, unexpected end of JSON input. That's interesting. Okay, let's see what went wrong. Init ops. Yeah. So this would be shared queue.js. Init ops. Yeah, let's add a debug statement here. So we need to use core print, and we print it to standard output. Yeah, ops map. Where did it panic? Unexpected end of JSON input. So we should be fine here, I guess. Okay, let's run it with backtrace. Oh, no export. Yeah, so this stack trace is not usable for us. Okay, why does it panic? Oh, I do know why, because I missed one of the arguments. So we have a promise ID in send now. Okay, let's try this. Yeah, I'll be back in 2 minutes, guys. Okay, let's run it again. Oh, panic again. Why is that? So we have, why does it panic? Okay, core print. This should print something to standard error. Unset Rust backtrace. Yeah, let's see this again. why there's no print? So core, yeah. Last ops map, is it different? No, that's the same. Okay, so let's debug it from Rust, and when we have call op, we can add print here. So op map JSON and pretty print pad. That's interesting. Op map JSON. Okay, so if we go to shared queue, and this is sand, yeah, so this is binded in API CC, I guess. So this is synchronous, so no op ID and no promise. Oh no, this is wrong. Yeah. Okay, let's see now. What? That was extra comma and it did not rebuild libdeno. Why is that? Yeah, so basically we have good output from Rust. This is okay. This is as fine JSON as it is. But then there's something wrong going on when we're trying to parse the received ops. And yeah, so we should receive bytes here. And this is Deno respond. So yeah, we're calling it with promise ID. And promise ID is here. Yeah, respond. None. Yeah, promise ID is here. Yeah, so it should be responding properly because we're failing on parsing. Then I guess from charcode is not working as well as I thought. Okay, let's try to get it to display. Ops map bytes. Why is this print not working? It's not called during snapshotting because we don't have snapshotting in Deno core. Share Q68, yeah, it's here. Okay, do we have anything in here? Oh, okay, so that's interesting. Yeah, ops map JSON, and let's add new lines. It's even more interesting. We were trying to print something to standard output, and actually it's not working, but for standard input it is. So ops map undefined. So actually returning the buffer is not working properly. Yeah, is it because of this comma here? Yeah, I guess so, but it's not rebuilding properly. So let's do this. Let's just remove it completely and see if it builds libdeno. It does not. Huh. Undefined. So debug, then respond. Okay, yeah, there are a lot of tests to update as well. Yeah, this is okay. Op ID. Yeah, this is fine. Then we have this. Huh, this is wrong. Yep, I did not update the header file. Yeah, I'm gonna leave this for later to update the test, but maybe now we'll get it to work. We won't. Huh. So demo promise ID, yeah, is defined here. Demo receive callback. This is set using demo core receive. That's fine. Yeah, so now the signature is proper. And in here, and in here. Okay, I guess I'm gonna have to nuke the libdeno build. Let's see, deno target debug. Alright. So yeah, maybe this. Okay, let's just remove everything that is libdeno. Target debug libdeno. Yeah. Oh, come on. Okay. Target debug Deno, then no core HTTP examples. Yeah. Yeah, just remove everything. Oops. Yeah, let's build this again from scratch. Oh, come on. Opsmap, opmap JSON. What is opsmap? Let's see. Yeah, so there are no bytes undefined. So send is not returning data properly still. Okay, so I guess the problem will be still here. The current arcs. Okay. Huh. Yeah, so everything here is fine in Rust, I guess. Let's just another debug. So promise ID in respond. Promise ID. Oh, too many. Yeah, so promise ID in respond is 0, which is good because we're doing a sync op. So it's a synchronous op. And so Deno respond should be called with promise ID equal to 0. Is it? Op ID, promise ID, yeah, it should. Yeah. Okay, let's go to send. Send inside binding CC. Send, yeah. Okay. Oh, in here it should be promise ID. That won't change a thing actually. Or would it? Yeah, and it's wrong in here and in here. Oh, I messed up badly. Okay, let's hope it compiles. It doesn't. Again, really. Yeah, so it doesn't work if 0 copy. Okay, receive callback. Let's see that. So this is Deno receive callback. And again, yeah, promise ID in here. Promise ID in here. Yeah, that's fine. So config, receive callback, pre-dispatch. Yeah, and in here respond, promise ID is fine. We always return the response via course return value. Okay, I guess we can ignore ID and promise ID in here. We op ID and promise ID. Yeah. In here it's all fine. Then we go again. Oh, not here. Then we respond op ID. Yeah. What's wrong in here? Set AB is import buffer from buff. So that's actually so it's a synchronous response, so it should finish here. Is the buffer not working correctly? That's like null pointer here would result in undefined in JS, I guess. So, okay, let's track this Deno response once more. So in here, yeah, buffer is the third argument, which is here. Okay, that's fine. Yeah, what the hell? Did I mess up here? No, it's promise ID in here as well. Okay, this is gonna be like really bad, but I'm gonna just nuke the whole target directory and rebuild it from scratch. Yeah, okay, cargo run. Yeah, it might take a few minutes. Okay, so let's recap what we did here. Let's leave it out. It's not working just for a minute. I'm sure we'll get to there soon. So we wanted to introduce another argument to Deno core send and Deno call an argument to call back to Deno core receive. So we can abstract away the whole dispatching infrastructure from implementers on the JS side. So we'll provide a single class that knows how to send messages to Rust given a buffer, control buffer. And then we want to receive the message, know what was the promise ID, and then call the appropriate deserializer on the received data. And actually, oh no. Writing GN options too. Oh. That's interesting. Will it run if I do this? Oh, it will, but it still fails. Oh, that's interesting. Okay, so... Okay, let's add some print in binding, in APCC. Oh, I don't really know C++, so this might be really lame. I guess it was cout. Yeah, responding. Oh, Deno responding for sync up. Look, it's still it's not rebuilding libdeno. What the heck? Why is that? Yeah, so this is still built by GN. So let's see what calls it. Build GN, core build. Is there something about libdeno? Okay, libdeno. Actually, recently there was a lot of changes to the build process, so this might not work correctly. That's interesting. So, okay. So, libdeno is inside core, so it should be built alongside core. And now, yeah, so here's this magic ninja. Oh, third-party depot ninja. Okay, I'm pretty sure if I run it by hand, it won't work. Okay, let me do this. So yeah, actually I'm cheating, I'm just asking for help. Okay, so alright, this error, what's the problem? argsgn, setup gn, generate gn, cacher. Okay, generate gn args. I think it might not like the fact that the gn args does not exist. Yeah, let's just see if this file exists. Cat, and if I touch it, Yeah, so this has to build. It should take less than 5 minutes. I'll be right back. Oh, sorry, I think I muted my mic and forgot to bring it back. Sorry, guys. So again, this is synchronous, so use 0. Yeah, in here as well. So control R. Okay, so I think this is asynchronous, and this is sync, I guess. Whoa. Yeah, and some more in here. So this is wasp instantiate. Do we have it here? We do. Deno promise ID, promise ID. Yeah, promise ID 1. Yeah, let's cut some corners in here and in here and in here. Do we have any more send method usages that we did not update? Yes, we do. So receive return empty. And yeah, we need to add promise ID in here as well. Yeah, let's check that it's 1. And it's 1. It's 1. Send. Okay, better. And there were some problems in modules test CC, I guess. Yes. Okay. So receive callback, Deno promise ID, promise ID. Oops. And that's fine. Let's assert that it's 1. Okay, okay, okay. Okay, let's see what errors we had here. Receive callback, yeah, we fixed that. Okay, let's try again. Yeah, will it work? Will it work? Come on, come on. Oh, nice. TLS landed. Oh, that's so cool. So um, yeah, I just checked and the Deno dial TLS landed, so now we'll be able to use SSL with Deno. Yeah, so I had this PR going based on work from Jonathan, I guess. Yeah, but some tests were failing and I was supposed to fix it, but I see Ryan got to it first. Yeah, nice. Okay, compiling. So guys, please tell me, are there any subjects that you want to know more about that I can talk to you? Um, I'm happy to answer some questions if you have them. Oh, come on. All right, my C out. Let's get rid of it. Okay, so once we get this to actually build, then this should start working, which means that we need to change the signature of this guy here. Okay, so but it still extends Deno core op, which we want to get rid of. But then, yeah, then once we have promise ID here, then we'll be able to move all of this stuff to the parent class, and the only stuff left will be this deserialization of the result. Okay, let's see how our build goes. Still compiling, fine. So yeah, let's rework this Deno core op into a concept that is not inside Deno core, but rather what we already had in Deno CLI. So basically this was inside dispatch file, and yeah, let's just put it here. Let's name it op. Yeah, that's fine. Let's quickly make a simple registry, which would be just an object. And then we have this op async callback, which will make an array, and then we'll look it up by op ID. Actually, registry should be. It should be. No, it's fine. Okay, so let's rework it. So this would be a registry, and then let's access it, and then. Oh no, this would be like this. And registry. And now we can implement the whole serialization, the dispatch logic inside these methods. So we need to copy the stuff from here, I suppose. Yeah, let's reformat it. And yeah, so let's trash this. And now we have op ID, promise ID, which means we can access our promise. Yeah, so okay, but then that's fine. These decode buff, and we add decode and encode methods, and now we can basically do this: return buff. So this will be moved to HTTP op. Oh, sorry, it's HTTP op. And then, and here is decode again. So this decode, and now we're returning record result. That's not what we want, or is it? Let's see, new promise. This is fine. Oh no, this is not fine. It uses send. This is this. So this is actually encoding step. Yep. So let's copy this, and it will go to encode, return scratch 32. So we don't want to serialize promise ID anymore, but let's keep it for now. Promise ID arg, and okay. Oh, it still doesn't compile. What the heck? What's wrong? No matching function for call to Deno respond. Why is that? Oh, Deno respond. And line 92. Why is that? Oh, because we're missing an argument here. So yeah, promise ID will be 1. And then 117. Yeah, okay, so I was clumsy doing this. Promise ID, assert this is 1. Oh, yeah. Promise ID, and execute, and then 104. 104. What is that? Okay. 166. Yeah. Then 183. Okay, not anymore. Receive callback, and then 199. Yeah, right, this is missing as well. Okay, compiling once again, and let's get back to this op real quick. So this is returning promise, and then promise is resolved with this decode buff. That is fine. Ah, right, okay, so this is basically just result. Yeah, okay. So class op. Yeah, okay, so let's rework this one. It extends op. It does not implement any of these three methods, but it will implement these methods. Okay, so sensing decode buffer, that's fine, and this will record.result. Okay, actually I think we're gonna change these signatures to just resolve with result of deserialization, and then it's our ops job to return the actual result. So let's do this right now. Yeah, decode and decode this. And now encode. So we're using send here and send here, which is not what we want. So okay, so the problem here is we want to call send sync with actually already serialized buffer, I guess. And then because this send sync is a static method, so it exists on the op class, but it's not available to instances of the class. And then I implemented the methods send sync and send async, so you can easily use them on class instances, which basically just call the static methods with ID that we get from the Rust. And yeah, okay, let's do it in here actually right now. Or do we? Okay. Yeah. So encode is not called because it's in send. Is it? Yeah, okay, so let's just copy this and add it as another static method. I don't like it that much, but yeah. And this will... So why is promise ID the first arg? Okay, it's fine. So const control equals this encode promise ID arg, and remember that we're encoding this promise ID just for the sake of compatibility. And then we get this, and then we get this, and now this. Yeah, it's fine. And from this, send async is actually, oh, sorry, it's async method. So we can do return await const res return res dot result. Yeah, just so we can see what's going on in here. Okay, I hope this will work. Let's see the build. Yeah, it's still failing. A few tests missing. Okay, let's fix this once and for all. 116. Yeah. It's missing promise ID in here. And then 118 receive callback. And then 113. Okay. So yeah, okay, we almost got everything we need. Now we just need to update the API in core. So init ops does two things. First, it registers callback for when we get the op IDs, and then it registers the callback for receiving messages from Rust. So actually, let's do it like this. Deno core. So actually, all of our ops, yeah, op dot handle async message from Rust. This will be our handler for responses, and then we do op dot set op map. Let's add this method real quick. So it's static set op map. Op map would be mapping between name and op ID. So if we go to here and we see the method called initOps, we'll change it. We'll take first CB and then set op map. So this is not needed. Oh, I hope so, yeah. And then, okay, so we're gonna actually call set async handler here, and then we do this, and then we call set op map with rust ops map, and all of this goes into HTTP bench set op map. So yeah, op vector, we don't need it. Then we go to op map and our registry, and then we call and op async callback, op constructor handle async message. Okay, so this will actually give us the handle async message from Rust static method. I don't think you can call it like this. It's a static method, so it won't exist on the instance. And yeah, keep in mind that this is really simple solution. Basically, we just have two local variables. But if this works, then we can move this solution to Deno CLI. And actually, in dispatch.ts in Deno CLI, there's already something that looks like this. It just needs some API polishing, because like in here, when we add an op, it can send sync and send async. And there are some ops that only support sync and only support async. So we'll have to add some options object to remove these methods and add validation that only async ops can receive messages, but that can be done later. Let's see how the build goes. Okay. Read file failed. So Deno.js main. What's wrong in there? Okay, so the build fails, but we should be able to run our example now. I hope so. HTTP bench. Yeah, so this is now working. Let's see if it will properly handle. 4544. Yeah, cannot read property resolve of undefined. Let's see. So promise ID in respond 0. So this should be sync. And we get is it really promise ID 1 in here? Sorry, 0. So op ID. Oh, let's do template string op ID. Then we print promise ID. And let's see what it gives us. So yeah, actually, the problem was before, the problem where we weren't getting the response from sync action was that libdeno wasn't rebuilt, but now we managed to rebuild it, and you can see that the HTTP bench bootstraps itself, so it synchronizes the op map and it starts listening. So now let's try to actually do some read and writing. Oh, core is not defined, sorry, it's demo core in here. Yeah, I'm interested why this promise ID in respond is 0. It shouldn't be, I think. Okay. Once more. Ah, right, okay, so promise ID is ignored in here because in shared queue we did this funny thing with handle async message from Rust. Right, okay, so I'm just gonna use this version for now to see if the core bench is working as it should. And in here, promise ID. Yeah, so now only core bench would work because we changed the signature of async message handler to include promise ID. And it's not like dual dispatch anymore. Okay, cannot read property decode of undefined. Yeah, it's a static method. Shouldn't I be allowed to? Okay, let's check this. So MDN static methods. Yeah. So I should be able to call one static method from another using this keyword. Static methods using the keyword from non-static methods. Okay, this is presolve. So static method, and this is static method as well. Huh, why is that? this constructor, it won't work because this is undefined. And actually we want to call it from the actual class that inherits it. Okay, just let's for now just use HTTP op. Yeah. Oh, sorry, it's not HTTP op, it's just op. So promise 836. Oh, that's interesting. Next promise ID. Okay, one more thing. 836, that's interesting. Why is it 836? It should increment. Do we have an, no, we cannot have an overflow. Next promise ID. Yep, there's still something wrong. Why is it 836? That is pretty interesting. So this is called with 836. Right. And so it should be isolate. Promise ID in respond 0. Why is that? Okay, another eprint ln promise ID inside async op. Okay guys, it's getting pretty late, so I think I'm gonna finish shortly. Yeah, that's interesting. Promise ID inside async op, it's 5, but then we get 836 in JS. Why is that? Okay, so we're gonna have to figure it out another time. Yeah, I planned only to do 1 hour of the stream, and it's like 2.5, so I think that's enough for today. Yeah, please let me know what you think, if you'd want to see more of it, and then surely I can do some more streaming with more work, and I hope next time it's gonna be way much smoother. But hey, we're poking at really like internal and critical stuff in Deno in here. Okay guys, so I'm gonna say goodbye now and talk to you later. Bye bye.